Arkadaşlar hoş geldiniz. İyi akşamlar. Değerli doğal yapı malzemeleri çalışanları, emekçileri, sevenleri. Önemli aslında bir webinar serisinin Mathieu Pedagama ile birlikte hazırladığımız ilkini yapıyoruz. Doğal Yapı Malzemeleri Derneği olarak. 7 tane Haziran sonuna kadar 2 haftada bir devam edecek olan bir webinar serisi düzenledik. Bu akşam ilkini yapıyoruz ve çok değerli bir konuğumuz var. Değerli Profesör Doktor Gernot Minke. Ben bir kısaca kendisini tanıtacağım. Bu konuşmayı Türkçe yapmak için de kendisinden izin aldım zaten. Mesleğimizin aslında bir duayeni kendisi. 80 küsur yaşında büyük bir enerjiyle hala çalışmalarına devam ediyor. Özellikle Kırsalda 3. Dünya ülkelerinde çok önemli çalışmalar yapmış birisi. Gernot Minke Almanya'da, Hannover'de ve Berlin'de mimarlık eğitimini tamamladı. Ardından da Stuttgart'ta Frei Otto ile hafif konstrüksiyon sistemleri üzerine çalıştı. Çok önemli çalışmalar yapmaya başladılar burada. Ardından da Kassel Üniversitesi'nde deneysel yapı laboratuvarını kurdu. Yani bu işte learning by doing dediğimiz eksperimental, deneysel yapı laboratuvarını kurdu ve özellikle toprak, kerpiç, doğal yapı malzemeleri, saman balyası konusunda ve çatı yeşillendirmeleri konusunda düşük maliyetli evler alanında önemli çalışmalar yaptı bu yıllar içerisinde. Bu arada yaklaşık 50 tane de topraktan tonoz sistemi geliştirdi. Yani toprakla açıklık geçme konusunda kemer, tonoz gibi konstrüksiyonlarda da çok büyük örneklere imza attı kendisi. Gernot Minke aynı zamanda bir sanatçı, ressam, birçok sanat galerisinde tabloları yer aldı, çalışmaları yer aldı. Bizler için tabii çok önemli bir kısmı buradaki yazar ve yayın çalışmaları. Bu konularla ilgili 300'den fazla makalesi var, bilimsel makalesi var. Yaklaşık 11 dile tercüme edilmiş kitapları ve yayınları söz konusu var. Bunlardan bir tanesi de Saman Balyalı Yapıların El Kitabı. Aslında bu alanda herkesin elinden düşürmediği, ben de şu anda göstereyim, benim de kütüphanemde yer alan çok önemli bir bilimsel kitaptır. Şimdi ben daha fazla uzatmadan sözü Gernot Minke'ye vermek istiyorum. Ve de bir ekran paylaşımıyla. Ja, Minke, ich habe Sie jetzt kurz vorgestellt.
Ja.
Und wenn Sie jetzt
Gut, dann
weitermachen. Ekran paylaşımını, bir provasını yapmıştık daha önce.
okay, good evening for everybody. İyi akşamlar. That is the only sentence I can say in your language. I'm sorry. I hope you can understand my English. I was asked to speak about earthquake-resistant houses built of earth, especially for rural areas, and I will concentrate on simple one-story houses. There are two possibilities to build earthquake resistant. One is solid, like these houses, which were built more than 300 years ago, and they withstood all the earthquakes of China. This is rammed earth and 90 centimeter thick walls with rammed earth. The other possibility is to build flexible. The engineers say ductile. So it is elastic and it will shake with the earthquake shocks, but it will not fall down. As this house in Guatemala, this withstood a very heavy earthquake.
Herr Minke, entschuldigen Sie bitte die Unterbrechung.
Ja,
wir sehen uns alle noch gemeinsam. Diese Bildschirmteilung, wir sehen nicht Ihre Präsentation momentan.
nein, wir sehen sie nicht.
Nein?
Die sehen Sie jetzt nicht.
Noch nicht leider.
Jetzt?
Nein. Die Merve schaut auch gerade. Es müsste eigentlich technisch klappen. Jetzt, ja. Mhm. Genau. Und jetzt, jawohl, jetzt haben wir es geschafft.
Okay, hätten wir gleich sagen sollen. Gut, okay. Aber meine Begrüßung haben Sie noch gehört, ja?
Die haben wir gehört, ja, ja.
Okay.
Vielen Dank. Auf.
So I will continue. Sorry for this technical problem. We have two possibilities to build earthquake resistant, either with solid, thick walls like these structures they will build 300 years ago in China and withstood all the earthquakes, or flexible structures like this wattle and daub system, which I will explain later, which is flexible. It could move in the earthquake, but it did not collapse. It was from Guatemala during an earthquake. Very important is the shape of the house itself. So we made some tests in our laboratory with a doctoral student. This is a heavy weight on a pendulum which chocks against this model of a house with a round ground floor, a round, was heißt ein Grundriss? A round shape. And after 3 shocks, this model didn't show any cracks in the wall. But the other one, which was square, had showed heavy cracks. And after 4 shocks, this fall down. But the round shape only had 1 short crack here, but it still withstood. Oh, sorry, this turned round. I don't know why. Let's go on. Okay, I can't move it. The position on a hill is very important. Maybe you can see overhead. If it is on an inclined surface, it's very dangerous. So it should be flattened and it shouldn't be at the corner. Maybe in my publication you have seen this more clearly. In a research project we did in Latin America, in the Andes, where we have a lot of heavy earthquakes every so often, we defined the errors which were made by single houses, 1-story houses. Always the same errors were made. First of all, there is no ring beam on the top of the wall, which keeps together the wall. Then the second one, the lintels are a problem. The lintels don't penetrate enough into the wall. 40 to 50 centimeters should be okay, but normally it's very little. So this will lead to failure. Then very important is the distance between opening. We see between the window and the door, there's a very small opening, which is a very small wall, which is dangerous. And the the next is there is no plinth underneath. So if it is earth and like adobe earth blocks, it is with a splashing rain, it will deteriorate very early. The proportion of the window is very important. We should always design vertical proportion and not horizontal ones, because this will weaken the walls. Then the roof should be very light and not so heavy, and it should be well fixed to the ring beam, so that it is very well united. Okay. One possibility is the foundation. The normal foundation is a stiff foundation, but there's an interesting solution which we checked, the so-called floating foundation. In this case, it's a bag filled with pebbles, with round pebbles from the river, stones. And here we see the plinth, and then the ramped earth wall. The wall is interconnected with the foundation by this stick. It could be bamboo or just any other stick. And in the earthquake, this is flexible. The foundation is, so it is called floating foundation. It will absorb the horizontal shock of the earthquake by deflection. This is a very new solution. Well, it's an old solution, but many engineers didn't know about that, and they have problem to accept it. One more thing is, here you see it's important to have a ring beam on top, which keeps together the wall elements. And if the wall is very long, we should make these fortifications, these pillars in between. So at least every 4 meters, we should have one, or it's better every 2 to 3 meters, like you see here. So the wall cannot bend, cannot go, fall out. There are possibilities to shape the wall elements in an L or as a U, so that against horizontal shocks, they stabilize themselves by their shape. We found out some proportions that have to be kept in mind. So for instance, the height, the thickness and the height is very important. The thickness should not be less than 1/10 of the height, for instance. And here are some possible solutions with stabilized wall elements, either by shaping them in a shape like a U, like a L or a U, or like an X. So these are different possibilities just by. So here we see a report of some earthquake tests which were made by other people. And you saw the lintels here. They fell down very soon, because where you have openings like the windows, you have always these cracks at the corner. So this was masonry work, bricks. And that's a problem if the lintel comes down. Here again, the lintels, here you see a very
Adamın sesi gitti.
What is the matter? Can you hear me? Hello?
Yes.
Yes? Okay.
War kurz weg.
The best solution is not making lintels like this here on the bottom, to have a ring beam which at the same time works as lintel. So you have two solutions in one, or one solution for two functions, it is very much safe than these solutions, these normal solutions. Sorry. Yeah, the proportions of the openings are important. So the distance from the window to the corner should be at least 1 meter. So never less than 1 meter. And the opening of the window never more than 120. These are just advices. Of course, these are not rules. We put all this in a manual, which was published several years ago in English, Spanish, and Farsi in Iran. But the publication you made in your institute now, it's more updated. But here you can see some more facts and examples. And you see my homepage. There you can see all my publications. So in Latin America, we built 5 different prototypes of earthquake-resistant housing. In '78, we built this rammed earth house with rammed earth walls. The plinth was done by local stones and some lime mortar and bamboo reinforced. You see a horizontal bamboo ring beam and these 2 inclined vertical elements which stabilize the ring beam. And on top, we made elements from rammed earth. They have this special shape of a T. So when you go up, and we had a special formwork which you can lift up, and then you can ramp it continuously in a vertical position. This is very important because most of the traditional techniques are horizontally, but this vertically is much better. Then you don't get horizontal shrinkage cracks. We have a shrinkage cracks here, a vertical one, which is designed to be an opening when it cures, when it dries. And we have 4 bamboo elements for vertical stabilization. So on top, you see a ring beam of bamboo in this case, because it was local material. And here you see the joints in the earthquake. It is meant that these joints can be open. It's a pre-designed opening joint because these elements, maybe I show it with my hands, can move this way, and even this way. So it's a flexible, a ductile structure, but with solid elements. So in the earthquake, only these joints open, but later you can fill them again with your thumb and with a little bit of earth. So it's no problem. And in fact, during this construction, we had an earthquake in Guatemala, and these elements, they really moved several centimeters, and nearby a church fell down, but this structure kept, there was no problem. This is a finished house. Important was another new idea. We separated the roof structure from the wall structure, as you see here. You see the plinth with the horizontal bamboo ring beam here, the ring beam for the walls on top, and these 4 vertical bamboo reinforcements. Because we analyzed the mistakes which were done and the houses which collapsed in the earthquakes in Guatemala in 1979, I think it was. In one night, 20,000 people were killed by the roofs coming down because the walls normally fell outside and the roof comes down. So in this case, we decided to separate the roof on separated timber structure. This is a wooden post, 50 centimeter off the wall. So in the earthquake, the roof can shake with different amplitude than the wall. And they do it because they have different mass and different height. So they have different frequency. We built another house at the same time in 78 from bags or hoses filled with volcanic earth, with pumice. This pumice, this is a light mineral aggregates which you get in an earthquake, like BIMs in German. I don't know what your word. Pumice in English. We filled it in cotton hoses, the hoses from cotton, normal cheap cotton weaving material. And then we put them in a mix of lime in order to save the cotton so that it does not rot. So it's again microorganism. The lime is very strong against any microorganism. And we put, as we see here, some bamboo rods on both sides with a galvanized steel. We fix this every 5 layers. And now we have a flexible ductile structure. You see here on the left, there is a post. So it's a timber frame structure with these flexible infill. Another rammed earth test house we built in Chile. And you see these elements have a shape of a U, and they are also stabilized with some vertical bamboo rods. And in this case, we also separated the roof structure from the wall. In this case, the posts of the roof were outside at the 4 corners. And we built another test house in Chile in rammed earth. The elements have a shape of an L or a U, so they stabilize each other in the horizontal direction. The roof was positioned on posts outside, and the windows are from the bottom up to the ring beam, to the roof. So in the earthquake, these elements, they can shake a bit. The window may break, but the whole structure will stay. It is a flexible structure, a ductile structure from solid elements, the same idea, but a different solution. Here we see these elements, rammed earth, and the bamboo reinforcement, vertical. And this was the test structure, the finished house. In Peru, we built in La Paz a dome. I will show the dome, such a dome as a cultural hall for the municipality. And we made it from adobes, made by hand. You see these adobes, they were made in these formworks. The formworks are from wood. The adobes, you know, adobe is a handmade, unfired earth block. They have 3 holes to make them lighter, to save material, and to increase the thermal insulation. And we put them in circles by the help of a rotational guide. You see here this rotational guide which we developed. So if one layer is ready, it can be lifted up to the next layer, and so layer by layer, the dome is finished. But the section of the dome is very special. It is not a parabola, not a catenary. Catenary would be the ideal form for a vault, a single curved vault. But for a dome, we need to have another line, which is this optimal section, this black line, which is similar to, no, it's quite different. It's a semicircle you see here, but semicircle is dangerous because in this area, up to 1/3, you get tensile ring forces. And in the earthquake, this might collapse. So many churches with these semi-sphere domes collapse in Latin America in the Andes. This optimized section guarantees that the forces are coming down are exactly in the center. So you don't have any ring forces. And we could make an earthquake-resistant dome structure, and it was calculated by the engineers. And here you see one of the indigenous people. They are cutting off the joints a bit to optimize the acoustic behavior. And then it was covered by acrylic paint reinforced by a glass fiber fabric. It's the inauguration of the dome. In Argentina, we built conventional concrete framework infill with adobes. It was the first and only time when I built with concrete, because the clients wanted to have it and wanted to get the guarantee that it is absolutely earthquake resistant. But you need very good concrete and good steel reinforcement. For the roof, we use this Hogan type of local material, local wood. But a very well-known system is the wattle and daub system, or in Spanish it's parareque. Here you see a traditional German timber frame house, and you have similar ones in Turkey I have seen, but not the small elements, but similar larger vertical elements, and infill with some vertical elements and horizontal branches woven, as you see here. In different workshops, we use different possibilities depending on the local material. Here it was in Mexico, a house. Here we use cut bamboo in Colombia. Here we used in Greece fine bamboo, which was imported, but always wooden grid bamboo grid structure. Okay, this is wattle and daub. Here another solution, but also wattle and daub. You see more exact the horizontal elements and the infill with a mixture of straw and earth. So this is cheap. It is labor intensive, but if you have local labor or you have many owner-built homes are done in Latin America, South America, especially up to Mexico, with this technique, because you can do it without any skilled workers, with your friends and neighbors. The bridge structure, maybe you build with professionals, but the infill, all these elements, you can do your own. We made a test of adobes with holes, so we could, as reinforcement, bamboo sticks in it. This is one layer. The next layer, of course, has these openings at the corner because we need this interlocking effect. Interlocking blocks are quite usual, often used in some countries in Asia. I think this is from Indonesia, but these are cement stabilized, compressed earth blocks. And you need vertical reinforcement. In this case, they used steel bars, and they filled the holes then with liquid concrete. So in my opinion, it's not the best solution because it uses a lot of steel and concrete, but just to show you possibilities which are used in the world. In Colombia, we used a very simple system. Okay, these are round posts from local trees. And here we have adobe wall. And you see every fourth layer, we put a barbed wire from one post to the other around. So we have now a reinforcement, a horizontal reinforcement from barbed wire every fourth layer, which is a very simple solution, but it gives good earthquake resistance for the wall. In Peru, we did a test on a shaking table. It's 4 by 4 meter to build an earthquake-resistant vault structure, which was pre-stressed by these metal strips, which were tensioned which were tensioned to the platform, and then it was tested by the simulation of the strongest earthquake which was measured in Lima. I have a video on that, and maybe I can show it later, the test. In 2015 in Nepal, there was a very huge earthquake with hundreds, thousands of people killed. And there we proposed, together with the Ithaca Institute from Switzerland, a simple technique to fill rice bags. These are bags from the market, normally filled with rice. We filled it with earth, with a clayey soil. And then we put some of bamboo sticks for interconnection in between. But on top, we made a ring beam from steel reinforced concrete. This is possible, this is necessary to get enough stabilization. And we have some vertical steel rods which go into the wall about 15 centimeters. The family itself, with some neighbors, worked on that, and they plastered later the walls with normal earth, with a very clayey soil, and you see the natural color. And then with the wooden elements from the houses which broke down in the earthquake, they built a roof structure, and later it was covered with straw from the fields. And our idea was that the family is building their own house, getting some friends to them. So about 12 to 15 people were on the building site, and always 2 from another neighborhood or another village, so that they can learn how to do it, and the idea is spread. And we gathered some money, and we spent 900 euros material costs for one house. And we had to pay 100 euro in local money for the engineer who was supervising the structure. So for 900 euros, the cost of one house was the cost of one house for the material and the supervision. The labor, of course, was free because it was the family themselves who built it together with neighbors. The problem was that these houses, we suggested this idea to international companies which built other houses there, but these houses were too cheap. These international help organizations, they wanted to spend $1 million or $2 million and not 900 euros for one house. It was difficult. That's one problem which I saw also in South America, that nobody in this capitalism system is really interested in very cheap solutions. Okay, my book, Building with Earth, was published in 15 countries by now in 12 different languages. I'm sorry, not in Turkey, but I think most of you will speak English, and there is a new English edition which just came out last year, and it was also translated into Japan and Russian and many other languages. Yeah, this was my talk, and I have now time enough for your questions, and I'm happy to answer your questions.
Thank you very much. Maybe you can show the shake test video.
Ah, yeah, sorry, I wanted to show the test.
Yes.
Ich habe jetzt Probleme. Wie komme ich wieder auf meinen Bildschirm?
Sprechen jetzt auch durch.
Ja, jetzt kommt es, glaube ich. Ja.
Ah, ja. Mhm.
Ja, das ist die Schalung, um die Form zu haben. Das ist eine umgekehrte Kettenlinie als ideale Form. Und da werden diese großen Adobes draufgelegt. Das sind sehr große Steine, sind 40 Zentimeter lang. Und das sind die Stahlbänder, mit denen das vorgepresst wird. Hier sieht man das, mit diesem Schraubenschlüssel wird da eine Spannung erzeugt von mehreren 100 Kilo. Und jetzt kommt der Test auf dem Rütteltisch. Das ist die Phase 3 mit der Tisch wird unregelmäßig bewegt, so wie die Simulation des Erdbebens war. Und man sieht, dass der Mörtel in den Fugen fällt zwar runter, aber die Form bleibt bestehen und sie wird immer wieder in ihre ursprüngliche Form zurückgezogen.
Ich übersetze es jetzt mal auf Türkisch, Herr Minke.
Ja. Ach so, sorry, I didn't speak in English. Soll ich nochmal zurückgehen?
Ja, wir können es gerne nochmal sehen.
Ich habe es vergessen. Okay, now in English, sorry. This is the formwork of the vault. And we put these adobes on top. The adobes are very large. They're about 20 to 40 centimeters. And you see the metal strips for pre-tensioning here. Some 100 kilos were forced in these strips. And then we put it on the shaking table in different phases. This is phase 3, where the earthquake was simulated with different shocks, irregular. And you see the shape is elastic, and it always comes back to the original position. Some mortar falls down because they didn't build an interlocking system. it was wrong. Normally you have an interlocking system and then you don't have these problems, but they built it arch by arch, very simple, and I was not there when they was building it. So in the first 4, we have 80 millimeters of deflection, of horizontal deflection. You see, the mortar comes out, but this is due to the wrong building without interlocking adobes. But you see, the structure itself, it keeps. It comes back. So it is a ductile structure where the kinetic energy of the earthquake is absorbed by deflection. That's the idea.
Yes.
So, wie komme ich jetzt wieder raus?
Bazı sorular var.
Şimdi soruları Merve sen görüyorsun. İstersen İngilizce olarak Bay Minke'ye
Okay.
direkt verelim İngilizce olarak ya da ben
Thank you very much, first of all.
çalışayım.
I think I can say the questions. Burcu Kunder has a question for the vault system, I think, for the earthquake test of the vault. Is there support or connection underneath the arc? In the test video, we couldn't see, as I understand. She's asking if there is a connection underneath the arc.
Well, this was a formwork which was taken out later. I don't know what connection you mean. Oh, at the bottom, there was a concrete plate.
Is it only the strips over the arc, or is there?
No, the strips were fixed to the foundation.
Okay, they are.
But I'm sorry, they only go over the arc. Is
Yes,
that
yes.
correct? They do not go under the arc.
No,
The
only
strips.
over. Only over.
Oh,
So it's a
I see.
pre-stressing of the whole structure.
Mhm.
Okay, I had a question because of my ignorance, perhaps. This earthquake test in the laboratory,
Yes.
is there how to say how many degree of earthquake it is corresponding?
Oh, this I don't know. The deflection was 80 millimeters. And the G was, I think, 0.8.
Okay.
Mhm.
Other questions? Another question about the vault test. Was the platform moving in one direction? Did you also shake the platform in the opposite direction or crosswise?
No. No, only this direction because this is a dangerous one.
Okay. The most dangerous one. Okay.
Yes.
Another question. Is stressing required in the longitudinal direction in
No.
addition to axial direction?
No.
Okay.
One thing, Minke,
Wie kriege ich jetzt meinen Bildschirm wieder weg?
we see still your screen. Okay, now we can talk
Okay, sorry.
together. Thank you.
Matthew has a question.
Hello, thanks a lot, Professor Minke, for this presentation. This was really good. And I had a question about this last example in Nepal, about this earthbag construction. I mean, how the people, I mean, was it definitive houses or temporary housing first?
No, it was one houses for one family. They lived with about up to 7 people in one house like this.
Yeah, but would it be definitive houses?
Yes.
Yes, they will be. It was not a temporary house.
No. They're living in this.
And I mean, I don't know anything about the normal type of houses in Nepal, but was it not a bit difficult for them to adapt to a round-shaped house?
Yeah. So we made two decisions. We made also a square house and a rectangular house, which they wanted. We built it, but it was so complicated and it was not so stable. So they were convinced later by the round house, and they loved it. First, they were very hesitating to accept it. I know this. But later they understood that the stability is the most important thing. And the rectangular, they had problems to stabilize the walls.
Okay. And of course, you know about all these core earth and all these dome-shaped houses. And would it be better to make dome-shaped houses or such kind of straight wall houses as you are doing?
No, a dome-shaped house has a very high resistance against earthquakes.
Okay.
But the openings are the problem, yeah? You must have a round opening, not a square one.
Okay.
And yeah, but I know it's unusual, and the problem is how to cover it.
Yeah, that's always the
Yeah,
main problem
but
for
this
domes.
with a dome is really difficult. I know. I have different solutions. In Latin America, we normally make green roofs, which is a bit expensive, but it lasts forever. And it gives additional thermal insulation, which is really amazing if the vegetation is really growing well.
But is it not adding too much weight after on
No,
the dome?
this shape, if you add weight in a equal proportion, it stabilizes the structure.
Okay.
Yeah.
Because of the shape by itself.
The shape is the optimum shape for only compressive forces to go down without doing forces.
Okay. Thanks a lot. Thanks a lot for.
You're welcome.
Thank you. Yelda, you have a question, I think?
Yes. Hi. Thank you so much, Professor Minke, for an inspiring presentation. And I also would like to thank you for all your research and books, which I benefited immensely for my PhD research in Cambridge. Actually, I got in touch with you about 2 years ago to ask for permission to use one of your images for the research paper we wrote about digital design and fabrication for Earth. And it is really nice to see you here and talk to you as well. My first question is about the earth mixes that you're using. You have shown a lot of different examples, especially in South America. In all these examples, have you always used local subsoil with only adding straw? Have you used any other fibers? Or have you used any other stabilizers, cement or other, especially for that dome blocks you did in La Paz, which has those like beautiful intricate shapes. I was wondering how you managed to get those hollow blocks without using any stabilizer, if that's the case.
No, we never use stabilizer. One example, I used it as a test because there was so much rain and we couldn't have a cover, so we had to put some cement to it. But normally, no, 99% of my structure without any additional stabilizers.
Excellent. That makes it perfect, actually, to be able to reuse it as well.
Of
So
course,
again,
but
I'm wondering like how you managed to get those hollow blocks in your La Paz project without any stabilizer.
Why?
Because like when we do trials, like they become like really brittle and like they're more prone to breakage if we don't like support them.
You must have a good proportion of clay and you must have enough coarse sand, enough clay, and some larger pebbles or large coarse sand. It's very important to have the right mixture, but you have to make tests before.
Yeah. Thanks for that. I might get in touch with you just about this if you have published the paper or about the recipe.
I published a lot. Yeah, the main book is the handbook on building with earth.
I'll revisit that part.
Yeah.
And the other question is what you think about the timber column earth infill structures as an alternative to, like, I really feel your agony when you said you had to build with concrete in Argentina because of the
Yeah, it was
client.
because the clients wanted it.
Yeah, and like, what do you think about like using timber columns
Yeah, normally,
instead with
well, all the other structures are used timber,
mhm.
skeleton.
Yeah, I also wonder this because, as you very well know better than me, is the behavior of timber in humidity. So when you use them next to each other, what kind of things, like, you, let's say, approaches you use to deal with this?
Well, if the timber is in the air and it's always drying, then it's no problem.
Mm-hmm.
And if the timber is within the clay's earth, it's also no problem, because the clay will suck the humidity.
Mm-hmm.
So if the clay preserves the timber,
Okay. So
you never get mushroom, or how you call this, fungus in
mm-hmm.
that case.
Mm-hmm.
But of course, you have to be in the earth, where in the foundation. This might be a problem, yeah, depending on the kind of timber and the kind of foundation.
Mm.
Sorry, I don't know why I didn't show the. There was one more project.
You would like to share the screen?
I will try again.
Okay.
Thank you.
Thank you.
No, it's no more here.
There was a similar question. I think you already answered, Mr. Minke. In wattle and daub system,
Yeah.
is woods needs to have a special features, or you use local wood there? I think you already answered the question.
I don't know. Did I show the water and dope system?
In wattle and daub system, do you need a special wood?
No,
I think
no.
resistant to clay. The question.
We used bamboo, we used any branches, we used oak tree. Oak tree, of course, is good. It depends. But I think, sorry, I tried to get back to my presentation. I think the last part was not shown. I hope to do it, but how?
You would like to, you should use the button below, share screen button.
Wait.
In the middle, it should be in the middle.
Yeah. But first I have to.
Onu önce
Almanca söyle istersen.
The PowerPoint was no more on my screen, so I had to get it. Now there it is. No, I think I'm no more in the presentation mood. Do you see it now? No?
Right
yet.
now.
Was sehen Sie? Sehen Sie jetzt meinen?
Nein, noch nicht. Haben Sie Ihre Präsentation aufgemacht auf Ihren Bildschirm?
Ja, aber ich sehe unten diesen grünen Dings nicht. Der kommt nicht.
Der grüne Share Screen Pfeil,
Ja, der kommt nicht.
der kommt nicht.
Ich
Oder?
fürchte, ich bin aus dem Zoom raus. Wo ist denn der?
Einen Moment, ich schaue kurz mal schnell. Jetzt? Ich habe nochmal Ihre Host geprüft.
Oh, ich weiß nicht, was da los ist. Vielleicht jetzt. Ja, jetzt bin ich da.
Mhm.
Jetzt müsste es klappen. Jetzt auf Bildschirm freigeben.
Jawohl, jetzt. Jetzt schaut es besser aus. Genau.
Wo war das von Beginn an?
Prezentasyon moduna gelmek istiyor herhalde. En üst menüde, en üst menüde.
O datay kısmında mı?
Kırmızı kısımda ben Almanca anlamıyorum.
Sehen Sie jetzt die Fotos?
Wir sehen jetzt links die ganze Kolonne, wo Ihre Bilder waren.
Ja. Ja, aber die Bacher Recke habe ich doch gezeigt. Das ist,
So, da haben wir alles gesehen.
ich
Soweit.
glaube, wir haben alles gesehen, ja.
Ja, ja, aha.
Ja, doch. Okay.
Da haben wir alles durchgemacht.
Okay,
Gut.
there are more questions, by the way.
Yeah, then more questions, okay.
Yeah. About the roof system, if the roof became too light, especially in the regions where there are too much wind, will it be a problem? They're asking.
Yeah, of course, but for the earthquake, it should be light. So it depends which is worse. It has to be fixed to the ring beam, the roof. And if it is fixed well to the ring beam and the ring beam is fixed well to the walls, I think there's no problem, even if it's light.
Okay. And about the shape of the roof, if the house is in, for example, L or rectangular shape, should the roof be in the same shape, or it could also be a rectangular plan house should have a rectangular roof or vault roof, for example? What do you suggest?
No, it could be any roof. A vault roof, you have to think about the forces, the inclined forces which come down to the foundation.
Okay, until the foundation. Okay. Yeah. Which material do you prefer for outside of the roof? Cover the roof.
To cover the roof?
Mm-hmm.
Well, it depends on the local availability.
Yeah. Mostly waterproof materials.
Normally it's a timber structure if you have enough wood, but if not, then a dome or a vault is good. For instance, in Iran, where you don't have trees, and they all build with domes and walls. Yeah, it depends on the area.
Yeah. Okay. About the rammed earth walls, for example, in Turkey also, for the earthquake resilience, they are using meshes in between the blocks, I will say. Like every 50 centimeter rammed earth and lay down mesh and repeat again. Are you also suggesting this kind of a system for rammed earth walls?
Sorry, I didn't understand this.
While ramming the earth wall,
Yes.
for every 50 centimeter vertically, when you rammed, you use a textile, a mesh, and then you continue.
A horizontal mesh.
Horizontal mesh.
Yeah, you can do this. I think Dr. Ziegert has used the system. I doubt a bit, because in the earthquake, the horizontal shocks are the most dangerous. And if you have these horizontal mesh, then there might be the problem that this opens. I prefer always vertical reinforcement, not horizontal, in earthquake areas. And you don't need this horizontal mesh. What for? If you have a vertical process, as we did in Guatemala, it is rammed humid and humid. Yeah, so it goes up. And then you have no problems with cracks.
Mhm.
But if you go horizontally, of course, and the second layer is more fresh, and the first layer is already dry, then you get problems of different movement of curing, or of how you call that,
You can say in German.
shrinkage, different shrinkage.
Linkage. Yeah. Mhm. Okay.
Efe, you have a question, I think, or add something?
Yeah, I have a question. Can you hear me? Yeah.
Yes.
Thank you for the presentation, Professor Minke. It's such a honor to see you here, like online.
Can you
I have
speak a bit louder, please?
louder,
Yes, please.
Yes.
like that.
Yes, that's better.
Okay. Thank you for the presentation, Professor Minke. It's such a honor, like, to see you here. Is it good? You're hearing, right?
Yes.
So I'm wondering about this countries like South America or other countries you work. How was the regulation for the earth structures? Is there a building code, or did you help to improve some earth building codes, or how was it? Or how is now?
Well, most countries don't have any building codes. And we build mainly on countryside. So that's not a problem. If you build in cities, you have codes, of course. There are even areas where it is, some cities in Argentina where it was forbidden to build with earth because of earthquake problems. But that's stupid, yeah? They didn't know how to build. We had analysis of earthquakes. I think it was in, was it Nicaragua, where all the houses broke down, even the masonry from bricks, normal bricks, and even concrete skeletons. So the earth structures, the traditional earth structures, some of them survived because they were very thick and were rammed earth. They had about 1 meter thickness or 80 centimeter thickness. So it's not the material which gives the problem, it's the structural system. And now, what was your question now?
So is it same now like that? There's still, like in Turkey is the same. We don't have codes, so we can build in countryside.
Yeah.
Yes, okay, same like Turkey, okay.
Yeah, normally if an engineer signs or architect signs a drawing, then you can do it. In some countries, it's different.
Mm-hmm.
But we have codes in Mexico and of course in California. And there is a group in Latin America who made a proposal for codes, which were not officially accepted, but some cities accepted them and you can build for that. Also, in my cases, sometimes if I can say in Germany, we have this code and it is due to this, then they may accept it.
Okay, thank you.
So another question is from Steve. In the shake test, the arch was standing up. The houses are cylindrical and laying sidewards. Did you perform shake tests on actual house configurations?
No, the shake test, the largest was this on this 4x4 meter shaking table in Lima. We didn't make other shaking tests. They're very expensive, and
Yes.
I didn't have enough research money for that. But I
So-
think you have a shaking test in Turkey, don't you?
We have one, and Bilge Işık, she worked with that.
Okay. What is the size of the shaking table?
Well, maybe she can answer. She's also with us now. Bilge Işık, if you can jump in and answer this. Bilge Hocam.
Sesi açtım. Aa, kendim de göründüm.
Yankı.
Low battery.
Çok yankı var.
Şimdi ama ben bunu kapatmaya çalışıyorum ya.
Çok kötü bir eko geliyor.
Şimdi nasıl? Ama
Hala kötü.
bu şeyi kapatamadım. Nasıl kapatacağım? Bir dakika. Bir yerinden tutmam lazım. What the space? Leave. Ha. Leave meeting. Tamam. Şimdi duyuluyor.
Tamam, güzel.
Peki. I used the shaking table in Ankara. We made the walls from bottom to top. It was not the rammed earth. It was shotcrete machine. Do anyone knows about shotcrete machine? It's injection. We took the machine from concrete construction and used it for earth injection into the wall on shaking table. And every 50 centimeters from bottom to the top, we put just like Merve called it, the horizontal friction layer.
Yes.
This is the first wall piece. You have a layer and the other 50 centimeter to the top.
Yeah. Okay.
When you have lateral force by earthquake,
Yes.
then it will move on this area, whether you have cracks or not. If you even have cracks, it move lateral,
Okay.
but it never collapse.
Okay. So that's also the idea of
That's
have
it.
deflection to absorb the kinetic energy of the horizontal forces. Yeah. Okay.
Mhm.
But you have then these gaps, these horizontal cracks.
It's about normally at the first force, you never have cracks on the shaking table.
Mhm.
We used 8 times earthquake test.
Yeah. Okay.
Then you have lateral, very fine cracks. You can
Mhm.
put sıva neydi?
And the
Plaster.
main structure was a wooden skeleton, or was it concrete?
No, it's load bearing.
It's
No
load bear-
skeleton.
load
I
bearing.
will send you the details of.
Oh, thank you very much. I'm very much interested. Yes.
Yeah, it's really very interesting.
Okay.
You know Marcel Blondet from Peru?
Yeah, sure.
Okay, he is
He-
also very much interested in it.
Yeah, he invited me once to a conference. Yes, I know him.
Okay, it's very good friend for me.
Okay.
Okay,
He did several tests in Peru.
okay.
Thank you very much.
Thank
So,
you.
I have one question about the time, Bauzeit. How long did it take? Because here in Turkey, in the earthquake, we are always in hurry, and one of the first questions are, it must be built in a very short time. So what about your experiences?
Well, the system which was used in Nepal with the filled rice bags, it was, I think, in 2 weeks they built the houses with 14 people.
Those people?
Mhm.
Earthquake house. I have a question, by the way. One of our civil engineer friends have asked the question in order to work on a rammed earth wall. He asked if you have made an elasticity modulus in laboratory you worked on. Please.
Well, no, but in my book we have some data on the E-modulus. I don't have it in my brain.
I think they need it in order to make some calculations.
Yeah, that's always a problem. Yeah, I know.
Mhm.
Yes. Here with the regulations and the rules, we are forced to calculate it, and the static engineers, yeah, they are looking how to do it. So your experiences are surely helpful.
But look at my book. There's some measurements of E-modulus are there.
Mhm. Thank you very much. Some other questions? Seçil, your mic. Seçil Hanım.
Gernot Minke benim Almanya'da diploma jüri üyemdi. Kendisine şimdiden çok tekrar teşekkür ediyorum. Ve benim öğrenciliğimde, ama siz çevirirseniz, Almancayı bile unuttum. Almanca sorabilirdim ama unuttum ne yazık ki. Siz benim öğrenciliğimde kerpiç çamurunun içine ormanların iğne yapraklı atıklarını, yani çamların iğne yapraklarını koyabileceğini savunuyordu. Acaba daha sonraki tarihlerde ormanların iğne yaprakları dışında da kerpiç çamurunun içinde geliştirdikçe gittiği ülkelerde neler katıyor? Bunu merak ediyorum. Ben geçen 2 yıl önce de kerpiç üzerine bizim okulumuzda yapılan kongrede kendisine anlattım zaten. O zamanı hatırlıyorum. Şimdi mutlaka çok geliştirmiştir içine koydukları açısından.
Çok teşekkürler. Ben o
Siz
zaman
çevireceksiniz. Ben unuttum Almancayı.
Tamam, ben hızlıca bir Almanca izah edeyim kendisine.
Können Sie das übersetzen?
Ja, ich mache es jetzt gleich, weil die Frau Seçil hatte, also sie hat zuerst gesagt, dass sie waren ihr Lehrer, also sie war Studentin bei Ihnen, und bei ihrer Diplomarbeit waren Sie auch in der Jury dabei. Also Sie haben Ihre Diplomarbeit zu seiner Zeit bewertet. Und sie unterrichtet jetzt in der Türkei an der Universität und hatten damals gesagt, dass sogar die Nadeln der Nadelbäume, der Fichten, der Tannen, die Nadeln damit eingemischt werden können. Und diese Methoden hatten Sie damals erwähnt, ist ihr geläufig. Wie Sie diese Zusatzstoffe im Lehm in der Zeit von damals bis heute, was Sie da für Entwicklungen erlebt haben, oder Nadeln, die man die getrockneten Nadeln, die man einfach sammeln kann, oder was da alles Besseres dazugekommen ist. Das war Ihre Frage jetzt.
Çok teşekkür ederim.
Ja, also es hängt von dem Klima ab. Wenn wir in feucht, in
Können Sie es auf Englisch bitte?
Oh, sorry. If we are building in subtropical or in humid climates, it is not so good to put organic material into the earth. So I normally use only pure earth. If we put straw, you get a better thermal insulation, of course, it's good, but you have to have a very clayey soil. So the clay must cover all the straws so that they cannot rot, they cannot get fungus. So normally we don't use organic material. With the needles, if it is needles from fir tree, for instance, which has a good resin, they don't deteriorate. So they are very good. You can mix it. And I know many use also hemp, cut hemp. You know hemp? Hanf. Hemp is good. It doesn't deteriorate so easy. And but mostly they use also some lime to it to avoid the fungus growth.
We use here in Turkey a lot of hemp. So we are used to, we know the material. And
Yeah, of
what
course, if you have local hemp, it's very good.
we are using it.
And of course, cow dung or horse dung is a traditional mixture which is used all over the world.
Seçil Hanım nasıl
Ben bir şey söyleyeyim ya. Ben
geçirmek?
toprağa gübre katılır pek çok yerde ve gübre organiktir. Minke organik katılmaz konusunu açtı. Dünyanın pek çok yerinde toprak ve gübre katılır.
Gübre, Dünger.
Ha.
Also Dünger wird in die Erde gemischt.
Bitte?
In die Erde wird Dünger gemischt.
Dünger? Nein.
In most of the construction.
Ja, also Kuhdung. Ja, also
Ja.
Kuhexkremente, ja, Kuhscheiße auf Deutsch.
Yani inek dışkısı.
Evet, gübre.
It's cow dung, yeah. Cow dung, which has an stabilizing effect against the water. It has a chemical reaction with some kinds of clay.
Evet, çok doğru.
If you have cows, a lot of cows nearby.
So, but you don't suggest especially using organic components in the especially humid environments.
Yeah. Okay, if you want a thermal insulation, of course you need it. Then straw is the best solution. Hemp straw, for instance. But you have to think about the condensation, yeah, of the dew point. That's the problem always. But if you have breathing walls, then it's normally no problem. And you must have rain shelter from outside, roof overhang, and the plinths, the normal solutions, structural solutions.
Thank you very much. Some other questions? Or I think not. So mach mal ein Schlusswort in dem Fall.
Okay.
Yeah. Thank you very much, Professor Minke, that you came to our invitation. And this was the first of our webinar. The next will follow in 2 weeks. We will inform it about via our social medias. And it was very helpful. Your presentation is very interesting, was interesting. We have translated it in Turkish. Çok kısa bir Türkçe söyleyeyim bunu. Çok değerli bir makalesini kaleme aldı, gönderdi bize. Dernek olarak biz de bunu Türkçe'ye tercüme ettik. Den Artikel, den Sie gesendet haben, dafür habe ich mich nochmal bedankt.
Ja.
So, thank you again. And
plus, hopefully we will see you in Turkey this year, at the end of this year. Perhaps Ant can also give this news to the...
We hope.
Okay. Well, thank you very much for the invitation, and I hope I could get some ideas to you. And if you will work on these ideas, I'm happy to help you. And if you have special projects, I'm always available for consultancy. Just let me know.
Okay. Thank you very much that you are with us.
Bir şey
Okay.
sorabilir miyim? Bu makaleyi nasıl edinelim siz çevirdikten sonra da
E,
derneğinizden mi edineceğiz makaleyi?
Seçil Hanım, sosyal medya hesabınızı takip ediyor musunuz? Doğal
Hayır, ben bir öğrencim haber verdi de öyle duydum. Çünkü 2 yıl önce Gernot Minke'yi bizim Fatih Sultan Mehmet Vakıf Üniversitesi'nde Gernot Minke'yi konu edinen bir bildiri sunmuştum. Dolayısıyla bir sonrakine de öğrencimle beraber katılmıştım. Ama inanın bu benim alanım endüstri ürünleri tasarımı. Fakat bu konulara merak sardım ve Bilge Hoca'nın da bizim okula bağı olduğunu da bildiğim için katıldım. Dolayısıyla ben geç öğrendim bunu. Onun için edineyim.
Tamam, size bunu ulaştıracağız.
Peki,
Şimdi
teşekkür ederim.
sohbete de yaz
Çoktan iyidir.
bağlantıdan
Çoktan iyidir.
ulaşabilirsiniz. Sohbet
Tamam.
kısmında.
Tamam.
Yeah,
Teşekkür
so what's
ederim.
Kaydı
your-
paylaşılacak.
comment?
Ve
Teşekkür
übersetzt.
ederim.
Okay.
Thank you very much for
Thank you very much again. And iyi akşamlar. Can you see this what?
İyi akşamlar.
İyi akşam.
Thank you very much.
Okay, bye bye.
Bye bye.
Danke.
Bye bye.